on?
So broadly, my research is at the intersection of technology, governance, and strategy.
Mm-hmm.
So what I'm interested in doing is looking at how technology impacts war and conflict, as well as cooperation. And then I'm also interested in the other direction. That is, how does war, how does politics impact technology? The use, the development, the innovation.
Mm-hmm.
I use two different areas
Mm-hmm.
to probe these questions.
Mm-hmm.
The first that I spoke about here is looking at things related to WMDs.
Mm-hmm.
So that is WMD counterproliferation, non-proliferation, counterterrorism.
Mm-hmm.
What are the trends either at the high end of terrorist capabilities, as well as, I think very importantly, at the low end, so the improvised terrorist capabilities. A lot of bioterrorism that I look at, as well as chemical terrorism. I also look at individual groups for case studies
Mm-hmm.
to understand in detail what are the capabilities, what is the motivation, how do these groups go about pursuing these different types of terrorists.
Mm-hmm.
The other side of my research is looking at emerging technologies. In particular, looking at what are some of the potential consequences of our own ingenuity. Are there technologies that are at risk for terrorist appropriation? What might those technologies look like?
Mm-hmm.
And how might we reduce the threat of malicious or otherwise negative use of technologies?
Mm-hmm.
So in my research,
Mm-hmm.
I have historically focused on nanotechnology and biotechnology.
Right.
Now, those are two broad areas, and I've also looked more recently at some of the cognitive neuroscience based technologies, and then how those intersect with our information and communications technologies. So that would be cyber everything.
Sure.
You know, in terms of specific technologies, one of the choices that I've made based on my research is not to focus on a specific technology,
Mm-hmm.
because no one's crystal ball has that fidelity.
Mm-hmm.
So it's not looking so much at a specific technology, it's understanding and trying to come up with ways to reduce the threat while not impacting the beneficial applications, not impacting legitimate research.
Mm-hmm.
So this is sometimes this is the governance side of it.
Mm-hmm.
And governance covers everything from international arms control treaties to the norms of behavior among scientists,
Mm-hmm.
publications, scientific journals. So it's the full sort of spectrum of different governance means.
Mm-hmm.
If one looks at actual use of WMD by terrorists over the last 100 years, more than 80% of the actual use of a WMD agent by a terrorist group has been chemical terrorism. It's not been biological. So again, it's looking at what terrorists can do, what's within their capability, and what they're likely to do.
Mm-hmm.
Now, it should be noted that terrorist tactics overwhelmingly still remain conventional style tactics,
Mm-hmm.
you know, or guns and bombs. But if we start looking within the WMD, I think that we have less recognized and sometimes minimized to our detriment
Mm-hmm.
risk of chemical terrorism.
Mm.
So I think you're hitting on a really important part of this, and yes, it's the failures of creativity. This is failures of creativity in terms of security studies and how we conceive of it. Historically, there's been a lot of emphasis sort of on the technical side, the material, the stuff.
Mm-hmm.
And from a nuclear standpoint, in many ways that's understandable because you can control fissile material. There is stuff that you can lock up. You know, plutonium is not found in nature. You can lock it up. When you get to chemical and biological, these are ubiquitous. And cyber, we can't lock up electrons. So it is just fundamental to the problems that just employing the models from nuclear are not going to be enough. And from my own work, I look at the importance of understanding the political drivers. What are the geopolitical threats that might push a state to make a choice one way or another? So what are the internal domestic factors? Right now, if you're looking at what's going on in Russia, there's a whole lot of it has to do with domestic drivers. You can look at a whole number of states where their international behavior has a huge component of internal domestic politics that they are then manifesting. In terms of things like cyber, this is where if you want to really drive and get to some of these issues, yes, we need people who are trained in political psychology. We need people who are going to understand organizations and behaviors. We also, of course, need technically trained people who understand what are the different systems, what are the vulnerabilities. So one of the pieces that I am increasingly finding is a reality of 21st century security challenges is these are problems that need teams of people. And it's not just that the problems are big, it's that the problems are complex and you need teams of people who have expertise that can come together to handle and to address these big, sometimes wicked problems. So my research in nanotechnology mostly has focused on the applications of nanotechnology that might be relevant to chemical and biological threats. Now, that's because that's the focus of my research. Now, if we're looking at nano-enabled capabilities, that's a much wider swath. Nano-enabled capabilities have to do with things like stealth materials, super strong materials, command and control, and sensors. That has tended not to be my area of research. And this goes to one of the challenges of dealing with emerging technologies is there's not a single thing. And particularly policymakers often want you to go, okay, this is what focus on. Well, it's not focusing on a single thing. There are certain pieces where we can bend down the spectrum. So when I'm looking at nanotechnology, I'm looking at what are capabilities that might either create new threats that are threats to biological organisms, or what are some of these capabilities that nano might enable that either increase the effectiveness of an already existing chemical weapon or biological weapon, or they enable a chemical or biological weapon to get around our countermeasures. I'm trained as an experimental scientist. My PhD is in chemistry, and what I worked on was the synthesis of porphyrins. So porphyrins are a carbon, hydrogen, nitrogen macrocycle that we're all familiar with because hemoglobin in our blood, the oxygen binding protein in our blood, is a porphyrin. Chlorophyll in trees has a porphyrin-like compound. Porphyrins are found throughout nature. They're very much a structural element as well as an active element. So I'm trained as a PhD scientist. I then became an entrepreneur, and that was critically important because that was where I started to ask the questions about why is the National Institutes of Health funding this? So these are science policy questions, but they're also questions of, well, how do organizations make decisions? And I became much more interested in thinking about these policy questions, including the questions having to do with the security issue, than being a high-tech entrepreneur in central Illinois. So I made this transition to technical security studies, and then eventually I was serving in the Department of Defense, in the Office of Secretary of Defense, which included some of the times helping design some of those programs, which enabled me to understand why decisions were made and that there are all these other factors that go into decisions. It isn't just cool science.